All right, this is lesson 2.2 in algebra, lesson 2.2, solving one-step equations. Okay, there are there's more than that. There's like 7 or 8, but we're only going to go over some of them today. Let me see. I think we only do, whatever. Okay, there's only 4 types that we're going to go over today. One-step equations. Okay, ready? Here we go. A one-step equation would be x minus 5 equals negative 4. Okay? We do start with negatives. I'm going to throw a little twist at you here, but here's the deal. What's the rule again? Anytime you have an equation, what should you do? Line down the equal sign. Next thing you do, well, first of all, is the variable happy? And the answer is no, he's not alone, right? He's a hermit. Not a Kermit, but a hermit. Okay? He's a hermit, wants to be alone. So he's not alone in his house. Who's with him? Right, negative 5. Or you could say 5. What's going on? How do I get that guy? How do I kick him out of the house? Right. Add plus 5 plus 5. Whatever you do to one side of the equation, you have to do the exact same thing to the other, right? That's the rule. It's just like the balance, right? It's just like the balance, right? Where you got the arm out here, right? And you got this thing, right? You got that guy. And if I have 3 rocks over here and 3 rocks over here, in order for this to say balance, which it has to, that equal sign tells you what? That it's balanced. The equal sign tells you that both sides are equal. So in order to maintain that, if I take away 1 rock from this side, I have to take away 1 rock from that side, and it will stay balanced. If I add 10 rocks to one side, I have to add 10 to the other side. It's got to stay balanced, right? That's the whole thing about an equation, is that it's got to stay balanced. Anyway, so okay. Minus 5 plus 5. What does that do? That negates it. That's why. What do we do? Why do we add 5 in the first place? To get rid of the negative 5. They're gone, right? They're gone. It actually equals 0, but x plus 0 is just x, so we don't write that. We just go x equals, and now we have a problem over here. Negative 4 plus 5 is 1. X equals 1. There's our answer, right? Super tough. Right, let's try another one. Let's go y plus 7 equals 3. Okay. Line down the equal sign. Is the variable happy? No, he's not alone. Who's with him? 7. What's the 7 doing to him? Adding. How do I get rid of that plus 7? Minus 7 minus 7. What you do to one side, you have to do to the other. Those guys are gone. That leaves me with y equals 3 minus 7 is negative 4, and we're done, right? Now, here's the deal. Here's the part that actually brings into play, you're in algebra, it's expected that you will be able to do this without any problem whatsoever. If I give you negative 1/5 plus m equals 1/10, it is expected that you can do this because this is simply adding and subtracting fractions, right? Nothing changes just because this is ugly. Line down the equal sign. Is the variable happy? Not at all. Who's with the variable? Negative 1/5. How do I get rid of that negative 1/5? Add 1/5. Add 1/5. I know that negative 1/5 plus 1/5 is 0. That's gone. That's not the issue. It's over here. 1/10 plus 1/5. I mean, you should know how to do this, right? Got to have a common denominator. Anytime to add or subtract fractions, you have to have a common denominator. Multiply this by 2, this by 2, comes out to 1/10 plus 2/10, which is 3/10, right? Right? Adding and subtracting fractions. No big deal. It is also expected that you will be able to do this. Little funky. Let's see. Line down the equal sign. Variable happy. No. He's got a 44.3. How do I get rid of that? minus 44.3 minus 44.3. Now, here's the deal. If you don't know how to do this, if you don't know how to... Listen, if I told you this, what is 3 minus 8? You all know that it's minus 5 because it's small, it's easy to wrap your brain around. But how did you actually get this? What were the steps that you went through to get this, Symbol Muna? Yeah, you reverse this. You know the answer is going to be a negative, and so now because of that, you can reverse it and go 8 minus 3, which is 5. My answer is not 5. You already knew the answer was a negative, so it's a negative 5. Just like this problem, is you look at this and go, okay, I have 21, and I'm taking away 44. You know the answer is going to be a negative. We're going into the negative. So what am I allowed to do here? What do you have to do? You flip them, and you go 44.3 minus 21.8. 22.5. Is the answer 22.5? No. We already knew it was a negative 22.5. Does that make sense? That is just life as an algebra student. You have to take... We learned all this stuff. You've learned all this. You just now have to put it together. You're in algebra. I'm not going to be teaching the basics like this. That was the extent of me teaching you how to add and subtract fractions because you're in algebra. Make sense? If you need a refresher course, not a problem. There are so many different things online you can go do to practice adding and subtracting fractions, multiplying and dividing fractions, adding and subtracting decimals, multiplying and dividing decimals. But we don't have time to go over the basics now. We're into algebra. Okay, what about this then? What if I have this? Negative 3m equals, I don't know, 6. Equals 6. What do I do here? Line down the equal sign. Is the variable happy? No. Why not? He's not alone. Who's with him? The negative 3. What's the negative 3 doing to him? It's multiplying him. What's the opposite of multiply by negative 3? Divide by negative 3. Divide by negative 3. Why did I divide this by negative 3 anyway? So that I would get rid of it, right? That was the point of it, was to get rid of him. M equals, what is, okay, a positive divided by a negative is a negative, right? You all know this? 6 divided by 3 is 2. M equals negative 2. Make sense? Line down the equal sign. Is the variable happy? No. What's going on? He's being divided by 4. What's the opposite of divide by 4? Multiply by 4. Multiply by 4. Why did I multiply by 4 again? To get rid of that 4. X equals negative 4 times 4 is negative 16, right? Negative times a positive is a negative. Okay. Okay, here's a... Ready? This is also, I'm going to show you some shortcuts here. I hope you're paying attention. 1/2 x equals, now we'll change that. 2/3 x equals, I don't know, 5, nah, 6, nah, I like 5/6. We'll just see. We did this a little bit last year. Line on the equal sign. Is the variable happy? No. Why? He's being multiplied by 2/3. What's the opposite of multiply by 2/3? Divide by 2/3. Remember, division is simply multiplication, right? And you know, listen, we could do this. We could go divided by 2/3 and go divided by 2/3. I could go divided by 2/3, but then I go, well, then what's the rule? You go, do you ever divide fractions? No, so then you go 5/6 times 3/2. Why not just skip that whole thing altogether? Remember, the same division is the same thing as multiplication. It's the same thing if you multiply it by its reciprocal, right? So instead of dividing this by 2/3, multiply it by 3 halves, right? Just multiply this by 3 halves and multiply this by 3 halves. We're going to get there anyway. It just saves you some steps. Why not? Well, look, what am I allowed to do here? Reduce, 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 reduce. They're all 1s, which makes it 1x, which just makes it x. That's why we did it. Equals. And now that I get to multiply this, let's start reducing. This becomes a 1. This becomes a 2. That's it. 5/4. 5/4. Now, in algebra, do you change that from an improper fraction to a mixed number? Generally, no. For real. At this point in your career, you're just going to kind of leave it. If it's reducible, if the answer came out to be x equals 9/3, you should reduce that to 3/1 and then reduce that to 3. Does that make sense? You don't leave a whole number on top of a 1. If it comes out to, x equals, 4/1, it's just 4. Does that make sense? You always reduce it. X equals, 12/6, that is 2. Or x equals, 14/6, you would reduce that to 7/3. Does that make sense? You would. Okay. I'm going to give you guys a small quiz just to see if you guys can do this. I can't imagine that you can't. Are we ready? All right, let's see here. On the first one, bind on the equal sign, always. Then, is the variable happy? No. It's being, what's going on with him? Who's in there? -14. How do I get rid of that? Again, this is a little bit funky. -20 plus 14. You got to be able to wrap your brain around that. Does this actually go back into the positive? Does this cross 0 and go into the positives? Cinder, does -20 plus 14 cross into the positives? Does this become a positive answer? At least give me a shake of the head. Right? No. So then, what am I allowed to do? How do you solve this? What can I do? 20 minus 14 is 6. We already knew it didn't go to the positives, so it's -6. Does that make sense? You can, adding and subtracting negatives is simple. Once you understand that, does it actually cross 0? What do I do? And okay, and you start subtracting. You flip it around, start subtracting. What if you got a problem that looked like this, people? Look, what if I ended up with an answer that said, -x equals 5? Is the variable happy if he is if he is the one that's negative? Is he happy right now? No, why not? Because he's negative. What do I do to change that? What do I do to change him from being a negative? What do I do to change it? What is the rule? What am I doing here? Where this happens? You guys don't know? Here's what happens, is you multiply both sides by -1. What does that do? By multiplying both sides by -1, what happens to everything? What happens to everything? All signs get flipped. What is -x times -1? X. What is 5 times -1? This becomes a positive and this becomes a negative. Everything gets flipped around. Yes, I heard you people say, yeah, you can flip everything, but you need to understand what, because you're multiplying both sides by -1. Makes sense? If that ever happens, you got to be able to do that. Okay, number 2, m plus 1/3 equals 5. Line on the equal sign. Minus 1/3 minus 1/3. This one I can do in my head. Some of you may not be able to. What did you guys come up with? 4 and 2/3, right? You take away 5 from 5, 1/3. That leaves you with 4 and 2/3. Hopefully you guys can do that in your head. Number 3, line down the equal sign. If it's a variable happy, no. Divide by 4. Okay, now here's the deal. Look here. We're dealing with a fraction over there. Do I really want to divide by 4? You're not going to, over here when I go divide by 4, is that actually going to be what I do, is divide by 4? No. What am I going to do over there? I'm going to multiply by 1/4. So then why not do that from the very beginning, right? This should be times by 1/4, 1/4 times, and this should be times 1/4. You all see why this gets rid of each other, right? The 4 becomes a 1, the 4 becomes a 1. It's all 1s. M equals. A negative times a positive is a negative. What is that? Negative 1/8, right? 1 times 1 is 1, 2 times 4 is 8, negative 1/8. How many of you got that? Okay. Number 4. Line down the equal sign. Is variable happy? No, he's being divided by -3. What could I do here? What should I do? Multiply by -3. Why not just 3? What if I did that? What if I just multiplied this by 3? First of all, am I allowed to multiply both sides by 3? I'm allowed to do whatever I want to, as long as I do it to both sides, right? So let's just multiply both sides by 3. What does this become? Do I get to cross those out? No. All of a sudden now, this actually becomes -x equals -27. Which, what do I have to do now? Multiply both sides. It's just an extra step. Why not from the very beginning just go, okay, times, multiply by -3 and multiply by -3, they're gone, x equals negative times a negative. Right, makes sense? How many of you got 4 out of 4 here? Raise your hand nice and high, I want to see it. Okay. Okay. You guys seem like you're in good shape. Let me give you your homework then. I think you guys are going to be fine. Page 86 to 87. 18 to 4. Whoa. 18 to 41 even. And number 64. 64 is a word problem, people. You have to be able to look at the problem, figure out what they're asking, write an equation, and then solve it.